tried doing the Google form last night.
Yeah.
And it said to sign in.
Yeah.
And I kept clicking sign in. And they
Oh,
go
yes,
stop
thank you.
it wouldn't let
It
me.
wouldn't let you fill it out.
No.
Okay. If you do have any questions, can you just write them down on a piece of paper and hand that in instead if it's not working electronically?
Thanks.
Did you do this? It wasn't me. That one was you. No, that one actually wasn't me. Hey, look.
Yeah, there's some on the counter over there.
Where's it at?
On the ledge.
I'm not dexterous. Dexterous? That's not it. So, I don't think that's all it is. Remember notes. I am ambidextrous. Like, you left my name. Like she said, I am ambidextrous. I'll be like, there is no how. There's a how. That's just you have what?
All right. Before we continue with our log properties today, I wanted to just take a moment and discuss what some of your options are next year for scheduling, because I believe that sophomores got their scheduling papers yesterday and juniors are getting theirs today. So after this course, you have quite a bit of options to take, and it can make it a little bit overwhelming because I'm pretty sure up to this point in your mathematical career, you really haven't had a choice as to what to take the next year. Like, you take Algebra 1, and after that's Geometry, after that's Algebra 2, after that is Pre-Calc, but after this course, you can start to branch off into different areas depending on what you're interested in. So seniors, just do me a favor and ignore me for now because this doesn't pertain to you. One route you can take after this course is the calculus route, which I'm going to go over in a little bit. Another path would be a statistics path, and then another path would be kind of a business route. So for calculus, we offer two courses. One is just an honors course like this one is, and then we also have an AP or college and high school course. We offer something similar for statistics. It's just that the regular statistics course is not honors. Okay, it doesn't have that weight, but we also do offer an AP stats course with the college and high school, so you could go that way. The business route would be financial management or accounting 1. Okay, I believe they count that as a math credit as well. Okay, so you basically have 6 options as to what you'd like to take next year. I cannot speak for the statistics path or the business path because I don't teach those. I don't really have much experience in those fields, but I teach both of these calculus courses, so I just wanted to give you some information about those. Whether you're considering one of them or maybe you're not sure as to which one to take, I kind of outlined some differences between the two of them. Okay, I would say the major difference is rigor and pacing. So for the AP course, I hope you realize we have to be done with the content by a certain time because we do have that AP test. So we're always doing something in class, whether that's notes or an activity or a discussion, something like that. The honors course is a little bit less, or it's a little bit more laid back, I'd say. I would recommend taking this course if you just want to get experience with calculus. Whether you take that in college or not, I'm not quite sure, but if you just want experience in calculus, this one would probably be a better fit for you. If you do want to go for college credit, if you are going into some type of engineering, mathematical, or medical field, I would recommend the AP. Just because you have that ability to get college credit for it, and it could count towards your college degree. Okay, so that might help you a little bit in that field, in that way. I also would recommend that if you know anybody enrolled in either of these classes, to ask them how they're doing. You can kind of get a feel for a student's perspective on it instead of my perspective as a teacher because maybe they're a little bit different. Okay, and we can obviously have a discussion individually if you're kind of torn between either one or if you have any questions in general. So I just wanted to give you some information in case you were kind of wondering which one to do next year or what course in general, like statistics or business, to do. Are there any questions that we might want to go over for next year? Maybe not now, okay, but if you do think of any, just let me know and we can have that discussion. I believe that since both of these are weighted courses, if you do want to take either one of these, you need me to sign off on it, okay? If you want to take AP Stats, I would have to sign off on that one as well. Okay, but regular statistics, financial management, accounting 1, I do not have to sign off on those. Is that clear? Okay. All right, so if you need me to sign off or you have any questions, just let me know kind of in between classes, at the end of class, whenever we have time, okay? Do we appreciate this? Was it?
Yes.
Yeah? Okay, okay. And I thought this would be a little bit easier for me to get to all of you instead of everyone coming up and asking me the same questions. Maybe this can help a little bit. Okay. All right, so let's go ahead and take a look at page 348. We've been dealing with these properties. Yes. We've been dealing with these properties of logarithms, and we were working on expanding logarithms yesterday, maybe condensing them, trying to use these properties to rewrite a logarithm in some fashion. So you might have to remind me, I forget where we left off yesterday. Are we on number 9? Okay. All right, so when you look at number 9, it actually looks kind of similar to number 8. So we might be able to use some of the same properties as in that previous example, but our ultimate goal is to start with one logarithm and try to expand it into 2 or 3 or 4, whatever number we are able to based off the properties. So don't feel like you always have to expand it to 3 or always expand it to 2. It just kind of depends on what properties are useful and kind of how the problem is laid out or telling us what to do. So can we take a look at kind of what's going on inside this argument and think about how we can start to break up those individual pieces? Kind of ask yourself, what is going on inside this logarithm, okay, inside that argument, and if we can utilize a property to our advantage. We see Caitlin, yeah? Okay, so notice how overall this argument is a fraction. Okay, it's some type of a division. So we can break up division by subtracting the top from the bottom. Okay, division and subtraction are linked, just like addition and multiplication. All right, I like that. So we went from 1 log to 2 logs. Let's see if we can start to use any other properties to help us either rewrite it or expand it, whatever the case is. Yeah?
3 logs.
Okay, so we can bring this power down as a multiplier. Okay, so we can rewrite that log. Can we perhaps use a property on this other log? Okay, Caitlin? They're going to add together because y is being multiplied by z. We doing okay from yesterday? Okay, now this is what most students would write, and I completely understand why you would leave it like this, but we do have to have a little discussion as to one extra thing that we have to be aware of, okay? If you take a look at this log that had the y and the z in it, notice how by the property you were supposed to be subtracting that log. So if you are subtracting this log, does it make sense that if you expand the log, you'd have to be subtracting all of the expansion as well? If you're subtracting the original thing, wouldn't you have to subtract all of its individual pieces? Does that make sense? Kind of? Like if I can think of an example, 3 minus 7, okay? I can rewrite 7 as 3 plus 4, right? What's 3 minus 7? That's negative 4. What's 3 minus 3 plus 4? That would be 4. Those two things are not the same, right? So even though I rewrote 7 as 3 plus 4, notice how I was subtracting 7? So does it make sense that I should be subtracting all of 7's individual pieces? Does that make sense? So if I were to distribute in that minus, what's 3 minus 3 minus 4? That's negative 4, okay, which matches the original problem. So what we kind of have to be careful of is when you start to use these properties, whatever sign or number, in this case negative 1, okay, whatever sign or number is in front of the log, that has to stay there as you expand it. So in this case, we should be subtracting everything that we expanded that log into. Okay, very similar to this number example. So I need to distribute in that minus sign. I'm hoping this number example helps. Can we see that? If we don't do that, notice how we change the value of the problem. Yeah?
How do we know that like we're not divided that one? Like, because we divided the first part, so how do we know if,
So you're saying, like, since this is being subtracted, you're thinking that these are being divided, right?
like, yeah, how would I know that these are?
Okay. Well, so I know that this log is being subtracted by this one, but notice how this log with a y is also negative out front. Okay, they're both negative. So you'd have to consider factoring out that negative, which if we do that, would change it to a plus, so you know they're being multiplied. Okay, does that kind of make sense? You kind of have that double negative there to be leery of. Okay, yes?
Does it matter that there's not a base value in anything?
No, it doesn't matter what your base is. So all these properties we use, they could be base 3, they could be a base e for a natural log, they could be a base 10 for a common log, it doesn't matter. Okay, so any type of log, you can use these properties for anything. Okay, good question, guys. Okay, so this is as far, I think, as we'd be able to take that one. I don't think we could really use any more properties. If you wanted to, you could probably check this, try to use the properties backwards, and you should get the original expression that we started with. Okay, if you wanted to take the time to do that. Let's check out 10 just because it's kind of similar. We're going to kind of see this concept again just for another example. So for 10, something I recommend noticing is that we have that square root there. So I would suggest writing that as a power of a half. All right, can we use a property to start expanding this log? Let's see, I notice how this 1/2 that I wrote is a power on the argument. What can I do with that 1/2? put it in front. Okay, so 1/2 log x to the third over yz. Okay, I like it. Now, if I continue to look in the argument, notice how I have a division. Okay, the entire argument is a fraction. So I can break up that division using subtraction. Okay, so I should have log of 3x, or sorry, x to the third, minus log of yz. The question is, what happens to this 1/2 that was in front of the previous log? What do you think, Maggie? There you go. Okay, so very similar to how we saw over here, if you have any coefficient, negative, positive, whatever the case is, in front of a logarithm, and you are expanding that logarithm, okay, breaking it up into multiple pieces, that number has to be moved to both of them. Okay, if it's with the original, it's going to be split up into the little pieces. It kind of stays with each piece. Okay, so we have that there. Let's see if we can keep going. Okay, let's look at one log at a time. So now in this log, I notice how I have yet again another power on the argument. So what I could do is bring down that 3 as a multiplier. Now since there's already a 1/2 out front, we'd have to multiply that by the 3, and that would give us 3 over 2. Alright, now if we look at the next log, we have that multiplication within the argument, so I should be able to break this up with addition. So I'm going to need a 1/2 log of y plus a 1/2 log of z. Now the issue again is, if I am subtracting this original log and I expand it, I have to be subtracting all of its pieces. So we have to be aware that we're going to eventually have to distribute in that minus sign. So 3 over 2 log of x minus 1/2 log of y minus 1/2 log of z. All right, it's a little tricky because I know we're just starting to get used to the properties, and I'm throwing in this little thing we have to be careful of, but I hope it makes sense that if you're expanding something, okay, every little piece in front of it has to follow with the expansion. Does that make sense? A little bit? Yeah? I'm hoping. Okay? So what I want us to try to do today is utilize these properties that we've been talking about with helping us expand or condense to solve log equations. So on the next page, okay, we're going to take a look at these bottom 4 for now. We'll revisit the top part later on. But now that we're in the groove of using these properties, I want us to see how we can relate them to equations. So if you look at 17, we want to somehow show that these 2 logs on the left are equal to this 1 log on the right. Do you remember when we were doing exponentials and we had like 5 to the 2x equals 25 to the x plus 4? Do you remember doing things like that? How did we approach exponentials? Okay, we tried to get the same base, and after we got the same base, we used some properties, like if we have a power to a power, we can multiply. And then what did we do after that? Okay, now that the bases match, okay, what's on the left is the same as what's on the right, we set the powers equal to each other, and then we solved from there, right? we're actually going to do something similar for logarithms. Notice how in 17, all of the logs have the same base. They're all that understood 10 as a common log. But what we want to do is eventually get one piece on the left to compare it, well, maybe this one down here. We want to get one piece on the left to compare it to one piece on the right. Because if our goal is to show that they're equal, shouldn't we have the same exact thing on both sides? Okay, that's what we want to try to show. So can we perhaps use some properties of logs to show how these two logs can become this one log? What can I do to condense, okay, change two logs into one log on the left side? Can we utilize any properties? What do you see, Blair?
Move the 2 into the power.
Okay, so this number 2 or coefficient 2 out front can be moved as a power on the argument of 2. So 2 squared would be 4. Okay, I like that property. Even though it's not helping us condense it just yet, it's still a necessary property to use. Okay, can we keep going on the left-hand side? Can we use yet another property? If we have log of x plus log of 4, yeah.
Multiply x and 4.
Okay, so our new argument would be 4x. Perfect. Okay, so we use some properties, and at this point, we have one log on the left and one log on the right with the same base. Just like for exponentials, how we had one base of 5 on the left and one base of 5 on the right. Okay, where do you think we can go from here to help us solve for this x variable? What do you think, Lainey?
Can we get rid of the log and set 4x equals x plus 1?
Exactly. Notice how when we did exponentials, we already know the 5's match, so we're not even going to worry about comparing those anymore. That's why we want to check to see when the exponents match. So on this side, we already know the logs match. We have one on the left and one on the right. We want to check to see when these arguments match. So we'll do 4x equals x plus 9. Okay, so very similar to how we did exponentials, like trying to get the same base, one on the left, one on the right. We're doing the same thing for logs. Okay, they should have the same base, and you should have one on the left and one on the right. You're just going to have to use some properties to help you get there. So if we solve it, looks like we'll get 3. All right, now, what's a little bit different with these logarithms than with the exponentials we did in the last unit is we kind of have to be aware or careful about checking this answer because logarithms have a particular restriction. And what I mean by that is notice how if I type in log of -7, it's not going to give me an answer. Even if I do log of 0, it's still going to give me an error message. So the moral of the story is whatever number we plug in for that argument has to be positive. Okay, the argument cannot be 0 or negative. Okay, so we have to be careful if there's a no solution type of result. So we're going to make note of that. Argument must be positive. Okay, it can't be 0 and it can't be negative. So what we have to do is check to see if this answer of 3 actually works in the original problem that we had. Okay, so for instance, if I plug in 3 into this first x in the log, notice how that would just give us an argument of 3, which is positive. So far that's okay. If I plug in 3 into the other x, okay, this is going to give me an argument of 12, which is still positive. So it seems like this answer we got is actually a solution because when we plug it back in to check it, our arguments are not 0 or negative. meaning there's no way for us to not be able to solve it. Okay, so we have to be aware that we have to check our answer. We can't just be happy that we got an answer. We have to check to see if it actually would work or make sense in the problem that we had. All right, let's try 19. We'll come back to 18 in a moment. Can we think about how we can change these 2 logs on the left to somehow match this 1 log on the right? Maybe not match it exactly, but we just want to get 1 log on the left and 1 log on the right. Can we use a property to help us do that? I have a log base 3 minus another log base 3. So if I'm subtracting the same type of log, how can I use a property? Yeah? Divide the arguments. Okay, so we'd have x minus 4 over 2. All right, so by utilizing that property, notice how I now have 1 log on the left, 1 log on the right. They're the same base, which is perfect. So since I already know the logs match each other, I'm going to ignore those. And I really just need to check to see when the arguments equal each other. So we're going to go through a little solving here. Let's go ahead and multiply the 2 over to get rid of that fraction on the left. So we can do 2x plus 2. And then I can subtract an x and subtract a 2. Okay, so my answer is -6, but I need to check it to see if it's actually a solution. Okay, does it work in the logarithms at the top? So if I take this x of -6 and plug it in to this first x in our logarithm, -6 minus 4 would be -10. Okay, clearly that argument is not positive. So even though this is an answer that we got, we actually have to say no solution. Okay? If this is the only answer we get algebraically, but when we check it, it doesn't work, that means there's no way that these 2 logarithms, if you subtract them, will ever be the same as this single log on the right. Okay, so you have to be aware of, even though you get an answer, you have to check it to see if it's actually a solution. Okay, does it work? All right, let's try 18. Maybe we'll deal with some natural logs. This time we have 2 natural logs on the right, and we want to somehow compare that to the 1 natural log on the left. Can I somehow use a property to condense these 2 natural logs into 1 natural log? Or maybe you have to use more than 1 property. What do you think, Blair? Yeah. Okay, there we go. We'll move the 2 up. Okay, so 2 squared would be 4. Okay, let's go ahead and see if we can use another property. We still have 2 logs on the right. If we are subtracting the same type of log, meaning the same base, we can divide the arguments. So now that we have 1 log on the left, 1 log on the right, they match. So I'm just going to ignore those. I already know those pieces are equal. Okay, they're the same. I just have to check the arguments now to see when those are equal. So which value of x would work in that case. So actually something similar to what we did in 19, maybe we can multiply the 4 over and let's see, I can subtract an x and add a 12. So x would be 12 over 7. All right, so it's an answer, but we have to check it. So if I were to take 12 over 7 and plug it into my first argument, I want to make sure that it's positive. So 2 times 12 over 7 would be 24 over 7. That's a little bit more than 3. So if I subtract 3 from that, this argument would definitely be positive. Okay, so I know that one's good. I also should check this x, but since it's just an x and I plug in 12 over 7, that argument would be 12 over 7 as well, so that would stay positive. So this answer, after we check it, works in all of the natural logs because all of the arguments are positive, so this is a solution. Okay, this is the value we would need to make this left side and the right side be exactly the same. Do you guys think you can try 20? Give it a shot.
You want to work, right?
Yeah. Nine over 11? Seem good? Did we check it? Did it work? Maybe, maybe not. Let's see. If I plug in 9 over 11 for this x and then add 3, will that argument be positive? Yes. Okay, so that one's good. If I plug in 9 over 11 into this x, times 2 would be 18 over 11. And if I take 18 over 11 minus 1, is that positive? Yes, because 18 over 11 is bigger than 1. Okay, so this answer works for each logarithm to make the argument positive. So that is a solution. Maybe we'll clarify this one. We'll say no solution because an argument would be negative. Okay, just so you have it in your notes to go back on, so you realize that's why we said no solution. Okay, are we starting to see how the properties are useful for solving purposes at least? Okay, we'll go ahead and stop there for today. We're going to save this top piece for tomorrow, just looking at some of the other properties a little bit more.
Mine are starting to get heavy enough. That's what I get.
Yeah.